Live stream Monday. Open space. All right. Hey everyone. Welcome to another Monday Open Space, where we just hang out for an hour and just answer your questions about space and astronomy, or whatever. Although I probably won't answer questions about whatever. As always, I need some kind of confirmation of my existence, some kind of reality check to the universe to know that I'm actually here. And until I get that, I will just assume that I'm just another disembodied mind. Hey, there we go. Some people said hello. How's it going? Before we get into this week's QA, just a little bit of housekeeping. The new people probably don't realize we do hiatus every year. We've been doing this for a decade with Astronomy Cast and with Weekly Space Hangout. So we wrap up our various live events at the end of June. And then for July and August, we don't do any live events. And then starting in September again, we pick them all back up again. So we are, and I'm going to be doing that with the open spaces as well. So I've got 3 more to do. I've got one today, one next Monday, and then one the Monday after that. And I might have some special guests. I've just put some placeholder events in, and we'll do that whenever, if I change them. And so we're still going to be releasing our regular guide to space videos. I'm still going to be releasing the regular question shows, but I won't be scrambling to find high quality internet many times a week. And so the reason we do this is just to really just kind of recover and get a chance to do some traveling and get a chance to spend time with friends and family and not worry the way I always do about trying to find reliable, fast internet every week, multiple times a week. So, but we may also do some random experiments. I know good friends at OPT are gearing up all of the live streaming telescopes. So we're probably going to do a pile of live telescope astronomy. So it's going to be a fun summer. But the Astronomy Cast, the Weekly Space Hangout, and Open Space will all come to a hiatus at the end of June, and then it'll all pick back up again in September. So, but also we've got the Star Party coming up on the end of June, June 27th, 26th, 27th. And we're going to record a bunch of live stuff there with me and John Michael Gaudier and Pamela Gay and Paul Sutter and Skylius. So, and I'll be posting a lot of that content here on the channel over the coming days, weeks. The other thing is that if you are watching this either live or after the fact, I want to remind you that everything that I do is put onto my podcast feed. So you can get that at universetoday.com/audio. So in case, like, I'm sure it's great to hang out and watch me talk on video, but I would want to see it as a podcast after the fact, personally, and listen to it at 1.5 speed while I'm walking the dog or something. So anyway, just don't forget, you can subscribe. Everything that I do, and with the podcast feed, I also throw in a whole lot of additional content. So whenever I do an interview, or whenever I'm interviewed, I'll ask for permission from the podcaster if I can add that audio into my feed, and then you can get that information that way as well. So there's a lot of additional content that gets put into my podcast feed. So if you're interested, but I'll warn you, there's a lot of content that comes out of it, so you sort of get a sense of how much is there. I don't do SoundCloud. It's just a regular podcast, an RSS feed. So you can get it from Spotify, iTunes, whatever. All right. Let me get the questions ready to go. Okay. So Rob Stewart asks, "Hi Fraser, does anyone in the space exploration sector believe Administrator Bridenstine's claim that NASA, with or without commercial assistance, can land humans on the moon within 5 years? I don't." Well, that's the thing about the future, is that we don't know what the future holds. Right? In theory, all of the pieces are coming together. So we've got the Space Launch System. There's the Orion spacecraft, which will carry the astronauts to the Lunar Gateway. They figured out partners who are going to be actually building the gateway. They know the power system that the gateway is going to use. They've found commercial companies that are planning on providing lunar lander services. They are testing out. They've already gone with a couple of lunar lander companies to land science payloads onto the surface of the moon, but also test out how to get to the lunar surface and see who does a good job of it and who is an effective partner to be able to do this. So it's actually pretty clever that the way that they're doing it. Will it all come together? Well, I've heard estimates that you need at least another $5 billion a year to make a lunar landing work, even with commercial partners. And so here you are with, so far, much less than that as approved funding. Who knows what's going to happen with Congress? So this is one of those situations where if everything goes right, if nothing goes wrong, then the experts say that it is possible, that NASA has put their stamp on it and said, we can pull this off. If you let us, we will pull this off. That said, nothing ever goes perfectly well, right? There's all kinds of problems that happen. You get, when you look at what happened with James Webb and look what happened with the Space Launch System, projects go over budget. Projects take longer than you're going to expect. So I don't, I would not be surprised if that 2024 date slips. But maybe 2028 sounds reasonable. Like I don't think we need to get all super upset if it's 2028. We haven't been to the moon in 50 years almost. And now it's going to take an extra 4 years. I could be patient. It's fine. And at the same time, there are other forces, right? It's not just NASA. You've got SpaceX, you've got Blue Origin, you've got the Chinese, you've got various interesting international collaborations and between companies, and things like Bigelow Aerospace and Northrop Grumman are planning a lunar mission. You've got the European Space Agency building planning a lunar colony. So I think that it's not the way it was back in the Apollo era. We've waited so long, but now there's a lot of forces that are all working together to make this possible. That said, there are a lot of great reasons to stay beyond just exploring it and beyond just putting another flag and demonstrating that the United States can still do it. So and until someone figures out some kind of economic reason for why to remain in space, like mining asteroids, space power, things like that, it could just be another boots and flag mission, and then the administration is going to change, and who knows what's going to happen. So that's my take on it, and I'm excited to watch it all unfold, and I really like what I'm seeing with all of the different pieces that are coming together. The use of, like, really how well they're embracing what's happening with SpaceX, right? The existing rockets, really considering using SpaceX for their various missions, helping to push Blue Origin into the race to provide some competition, all of these private lunar landers, and yet at the same time collaborations with international partners. It all sounds fine, and I won't be surprised if it takes too long. This takes longer. That's just how this works. Bill Sugden is saying, do you get annoyed by the hand wave local government gives to dark skies? Locally, we've had LED streetlights installed that are worse than we had beforehand. Right, so this is actually a bit of a controversy that came out over the last couple of years, that all of these cities have been installing these LED streetlights, which are reduced power, and in theory they can be directed at the ground so that they reduce the amount of light pollution that's happening in the skies. And the terrible, ironic thing is that because they generate less power, they're cheaper to use, and so people are installing more of these things, and they are making the problem of light pollution worse. And it's super frustrating, and we should get to a place where we could have a minimization of light pollution, but we're not moving in that direction yet. And I think at the end of the day, it's going to come down as it feels like a safety issue, right? If you have LED lights that are putting out less light into an area and people have to walk home at night through a darker area that keeps the skies really beautiful, they're going to feel less safe. And I think until we can figure out a solution to that, we're not going to solve the light pollution problem, unfortunately. But definitely getting rid of the sort of the sodium lights that just broadcast into the sky, that would be great. Lucas Johnson, do you find it hard to stay fascinated by astronomy and science after all this time? Not sure what it is, but I have a hard time getting excited about new discoveries when it seems more of the same. No, and I get super excited. I mean, I've been doing this job for 20 years, and every time I don't do this job and do some other job, all I want to do is get back to this job. And a big part of it, I think, is all of the new discoveries. And I think what happens is as you learn about a subject like space astronomy and the state of space exploration, you learn the nuances and you see this all unfold. And so instead of it being, oh, we've discovered a new planet, it's we've added new discoveries into the Kepler from the Kepler data, or we've discovered a planet that's closer into its star than we've ever seen. And the thing that I really get excited about is the sort of the cutting edge stuff, the technology that is right around the corner that people are proposing. Here's a clever way to overcome some problem that we're having with space junk, or ways to connect telescopes together, or interesting ideas to observe Alpha Centauri or things like that. And I find that as you learn more about it, these incremental improvements they're more tangible and they become a lot more interesting to me. And so I think that it might just be that you're not into it. Like you may get to this point where you're like so blown away by all of the vast grandeur of the universe, and then you've watched a bunch of things and you're like, nah, I'm kind of done now, and you want to move on to something else. I'm sure there's some subject that you love to watch unfold every single new discovery. And there's a bunch of things like in video games that I'm all over. I'm learning about every new update that comes from the games that I play because I'm into it. And then as soon as I'm not into it, I don't care anymore and I move on to something else. And it might just be that that's where you are with space. And maybe you're going to go on to a new hobby. And then maybe you'll come back around later on. Or don't. It's your call. So I think that for me, a big part of maintaining the work that I've been doing over the 20 years is that I also just enjoy this process of running the website, of interacting with the audience, of figuring out how the new technologies work and integrating that into my career. And it's a puzzle that I solve every day, and I really enjoy it. And I'm sure it could be about almost anything. It happens to be about space, but if I was running websites, if I was a journalist about video games or mountain biking or Canadian politics or whatever, I would probably still be as fascinated about that as well. That's the part that actually that's the part that keeps me entertained. So, and it happens to be that I work in a field that I really enjoy and I'm really fascinated by the topic as well. So you kind of want to have both. Tesla Ranger, do you think space travel will ever be as ubiquitous as airline travel, or will passengers always need highly specialized training? Good question. I'm going to say it will eventually be as simple as airline travel. But if you've ever taken like a cruise ship, you find that you get on the cruise ship, and then within the first hour or so, they will take you to a muster station and explain how all of the procedures that you have to go through in case there's an emergency on the boat, and how to evacuate, and where you go to get on your lifeboat, and all these kinds of things. And so it definitely brings back that awareness that even though you are on a big boat and you're about to feast for 7 days and make yourself sick, you are on a boat, and the boat is on the ocean, and shipwrecks have happened, and there's a little danger there. And I'm sure it'll be something like that. And same thing with airline, that any amateur will be able to get on a spacecraft because it will have all kinds of redundancy and levels of safety. But at the same time, to go from the surface of the Earth to orbit, you have to go from 0 to 28,000 kilometers per hour, going through the atmosphere, experiencing temperatures on your spacecraft that are beyond the tolerances of most materials. It will always be dangerous. So no matter what, the laws of physics will just demand that space travel is a very dangerous thing. Rami Ahmed, Nancy, are you in the same room with Fraser? No, Nancy is on the other side of the United States somewhere, I think. I don't know. We've only met a couple of times. Let's see. Thanks to the moderators who are putting all the questions up so I can see them all in one place. Grumman Pilot 99. Didn't President Trump just tweet out that we're not going to go to the moon anymore? All right, I will tackle this if people will not have a big argument about politics in the chat, because I don't want that. So here is my Canadian balanced view on that. I heard, but Trump got a lot of heat over saying that we're not going to the moon. Now we're going to Mars, and the moon is part of Mars. Now, obviously, the moon is not part of Mars, and that's not what he was saying. So I think it's kind of ridiculous to say that he was saying that the moon is literally, physically part of Mars. He was saying that, obviously, going to the moon is a step in the process of going to Mars. And I think that he's been pretty consistent about saying that Mars is the big plan. It's that cooler heads are recommending to go to the moon first because it's close and the technology is more straightforward and within the reach of the current technology. The Space Launch System, the Orion capsule, those can go to the moon-ish. They cannot go to Mars. And so you can't just go to Mars. One does not simply go to Mars. One has to build up infrastructure. And the first step that you do is you build up the infrastructure to eventually go to Mars. So I think it's the plan that I think we all were expecting, was that Mars is the long-term goal, but the moon as a closer place is an easier stepping stone before you go there. I personally disagree. There, it's all backwards, sorry, right? I like asteroids, I like orbital colonies, but if we're going to go somewhere, let's go anywhere. And the moon and then Mars, fine. Let's do it. Gregor Samsa. Do you think there's even the slightest possibility that extraterrestrials visited our planet in the past? Great question. So here's the thing, right? Which is that if extraterrestrials visited our solar system in the past, what was the method what was their plan, right? When we travel out into space, when we go out into the universe, and we're going to build our self-replicating robot probes, our von Neumann probes. They're going to dismantle asteroids and travel from star to star as they go, consuming the asteroid for fuel and additional resources. Then they're going to get to another solar system, and then they're going to convert as much of that solar system as more von Neumann probes and send them off in other directions. If extraterrestrials were here, where are they? Right now, it could be that their machines are long gone. It's been a long time, but then why didn't they stick around? Why didn't they turn this entire solar system into part of their galactic empire? And then if they failed, what about the next one? Why didn't extraterrestrial civilization 2 come along and add soul to the empire, or then the 1000th or the 15,000th? So it's easy to explain why one might have failed to leave any evidence that they were here, but it's hard to explain all of them not leaving any evidence that they were here. That's the part that's weird. And that's, of course, the Fermi paradox. And that's again, as always, anyone who thinks they understand, has an answer to the Fermi paradox, hasn't thought enough about the Fermi paradox. the Kirov 099. Where can you get that poster? There's only one. That one right there. That is the poster. At some point, Aaron Wood designed the poster for me. He's the same guy who designed the Pluto, the planet. Oh, it's all backwards. There, all the planet posters, and so I had him make a Gravity Wells Are for Suckers poster. I may make a downloadable version at some point. I'm not going to get into the poster printing business. It's madness. But I may make a JPEG available so you can just make your own, print your own, and you'll have a version of the poster. I have no idea what Frey Funk is. You're going to have to explain more information. Let's see. Rami Ahmad, what is the most important invention in the past 20 years that will have the greatest impact on our future? In the last 20 years. It's weird. Like you go back, say, 100 years, and there are tremendous numbers of big, dramatic changes, right? Rocketry and airplanes and automobiles and central heating and air conditioning and refrigeration and all of these computers, right? All these big technology advances, telephones, televisions, and yet in our modern age, it feels like a lot of the things that we use today are refinements on things that were already figured out. Like they had rockets 50 years ago, but they don't have rockets that land on their own launch pad or beside their launch pad. They have computers, but they don't have a computer that's that you hold in your hand and connects. So I think that the internet, if I was to pick one thing, it would be the internet. The internet is the thing, and obviously there was networking. I mean, ARPANET, and I know that it's been around for longer, but I've been doing this job for 20 years, and I was really lucky that I got into web development literally at the beginning. 1995 is when my professional career really kind of started, and I was able to be on the ground floor as the internet took off. And it was dramatic. It was unbelievable to sort of experience before the internet and after the internet. I mean, there's this great comic, I don't know if you've ever seen it, where two, I think, dogs are sitting side by side, and it says before Google, and one is just saying, I just thought of something that I want to know more information about, and the other one says, that's a damn shame, right? Like you can have a question pop in your brain, and then you can look it up or ask me. So the internet is the thing that's changing everything, and will continue to change everything. We are connecting all of humanity into one place, and we will all talk, and we will be able to buy and sell things from each other and share information and be more extreme towards each other, but also waste our time and learn. It's amazing. Space TV, if you were the captain of a starship, what would be your first destination on your maiden voyage? Man, I would want to go see Enceladus, Titan, Iapetus. I want to see a lot of the crazy icy moons. So beyond that, we don't know where, we don't have enough information. I would love to go to Alpha Centauri and just see if there's planets there. Proxima Centauri, we know there's planets there, but do they actually have life on them? So that's probably where I would start, because they're close. Let's see. So Mike Doman, will there be some Universe Today or Weekly Space Hangout merch? The Weekly Space Hangout is up to the Weekly Space Hangout crew. They really are the executive producers of this whole thing, and they're free to make whatever they want. Universe Today merch, probably not. We did merch with Astronomy Cast back in the day, and I think you sell a couple of mugs and a couple of T-shirts, and you're like, nah, it's not a great use of time and investment, so probably not. What I'll probably do, my plan is to give a bunch of stuff away as part of for the patrons. So we did mission patches in the past, and I've got a 2019 mission patch in design, and what I want to do is give out a mission patch each year, so that people have been patrons, and it's looked like something like it's a space mission, but also it's like whatever is the big key space discovery of the year. Like, so maybe 2019 would be something like a sad opportunity. Oh, by the way, today is 1 year since we received the last signal from Opportunity. Yeah, oh, sad trombone. So it's been a year since Opportunity sent this last picture. On Bird, do you think there will be a time when individuals shop for personal spacecraft the way we shop for cars? No, I don't think so. Maybe. Um, when we get to a time in the future when there's like a vast amount of resources that are available to every human being, right? When you look at, say, all of the resources of the entire solar system, and you divide that up by the population of the future humanity, then that's a lot of money. Everyone is a billionaire, right? Everyone is a trillionaire. And so maybe you can afford your own spaceship because you've got robots that are out there that are gobbling up asteroids and turning them into your own personal spaceship, and that would be great. But it would mean that there's a lot of wealth for everybody, which would be a wonderful thought. So I hope we get there. I mean, again, even the poorest people in our modern society have access to technology that would be unthinkable to people hundreds of years ago. So you can see these improvements happening year after year after year as humanity grows. So someday, your own personal spaceship. Dustin Clemens, do you think something is looking back at us? No, I don't. But, are there alien civilizations out there looking at us? This is back to the Fermi paradox. And my personal opinion is the Fermi paradox is a really scary thing to think about. And the answer is, to me, is that we are probably alone or the first civilization, or we're about to be doomed by the Great Filter. And so, there you go. Robbie Rose, when do you think Cthulhu will rise from his watery slumber? Cthulhu Ftagan. Des385, how long before we see Starlink supply as service available to average consumers? Good question. Okay, so it looks like some version of Starlink is going to be available in 2020, 2021. So that'll be like a year to 2 years, and that's when they're going to have the first 360-ish satellites. 6 launches, I think, is when they can get a completely basic service going. But we don't know what the speed is going to be, what the bandwidth is going to be. So it's probably going to be the 2000, 3000 satellite version when we start to get usable internet. But it is still a complete and total wild card. I mean, like we don't know how good this is going to be and how cheap this is going to be. On one end of the spectrum, it's going to be on the iridium level, where you're paying $10 a minute to make a phone call, and you're paying a large amount for data, and so only rich people will be able to use it, and too bad for most of humanity. And then Elon Musk will need to apologize because he said that it would be available to all of humanity. And then the other possibility is that you might go and spend a couple $100 and buy a receiver, and you put it somewhere, and then maybe SpaceX gives it away for free and they just sell the receivers. That would be crazy, right? Unlimited high-speed internet, and you don't even pay a monthly service. You just buy the receivers, the tech from them. So it all depends on what the prices are going to be. If they're getting their construction and launch costs down low enough, they could create a service that is incomprehensible for anyone else to be able to to compete with. So right now we have no idea. I've heard like in the $50 per month range for a high speed internet service from space, but no one's really given us a firm number yet. Space TV, would you rather be an extra on Star Trek, Star Wars, or Rick and Morty? Oh man, probably Star Trek. I don't think I could keep up with Rick and Morty. Wouldn't be funny enough. But I do love Rick and Morty. Cannot wait for the next season. I think it's like the most wonderful thing that's been put on television in the last 5 years. That and The Expanse are just two wonderful things. Sprinter 768. I know that you think a space elevator is a bad idea on Earth, but isn't the only way to make getting to space relatively safe and worth pursuing despite the enormous engineering challenge. So that's a great point. The problem that I have with a space elevator is not that it's challenging, it's that it's actually probably not going to be cost effective compared to reusable rocketry. So one of the calculations that I've seen is that the Starship will get the cost per kilogram down to about $75 a kilogram. And that's sort of in the same realm or even cheaper than a space elevator, which is crazy. Now, you mentioned safety, and I think you're exactly right. There's some pretty interesting safety improvements because it's just an elevator. It's going up through space very slowly, making a change in its orbital velocity, and it doesn't experience those extreme temperatures. But at the same time, it is slow, and it will take you a week to reach the geostationary altitude. So I just don't think, personally, that we will be able to overcome the materials challenges to get a space elevator built. And even if we do, there won't be the economic drive to do it compared to all of the reusable rocketry. And then the other thing is that I don't think that we really need to launch stuff from Earth for very much longer. So we're in this weird time where we need rockets, where everything that we want to put it up into space is down on Earth. But fast forward 50 years from now, and you're going to have self-replicating robot factories that are out in space that are dismantling asteroids and fashioning them into the things that you're going to need in space. And so the only thing that you need to take off of planet Earth is going to be us, the traveler, the meat. Everything else will already be harvested out in space and ready to go. In fact, it's going to be the other way around. You're going to be returning stuff from space down to Earth. And we have ways to be able to do that with capsules and things like that. So I think that we're going to see this time where we actually can't think of a lot of stuff that we want to send to space anymore. You get in your rocket, you fly to the space station, and then everything else is ready to go out there. All of the mining facilities and all of the space stations, it was all built out in space. So it's a paradigm shift. And it's something I've been thinking a lot about. And I've mentioned this a couple of times, and I want to probably do a video on this, like the end of rockets, because we're so excited about it now because that's our concept of how we travel to space. But in fact, I don't see it lasting forever. I don't see it lasting for long. Like SpaceX, if you're listening, Elon Musk, I wouldn't stay in this business for too long. You're going to get disrupted by whoever figures out space-based manufacturing. That's the big one, right? Josh M., do you think that space planes will ever be a viable form of fast travel? Possibly, although, again, it's really hard to compete against the fully reusable multi-stage rocket like the Starship. Like the Starship is the version that is the cheapest. And when it comes to flying things to space, I mean, we've seen the Concorde, right? The Concorde was a way to travel at multiple times the speed of sound at dramatically more expensive than flying slower on an airplane. Because, yeah, it's great to get between Paris and New York City in 3 hours instead of 6 hours, but at the end of the day, it's just 3 hours. So I think we're going to have the same situation, that nothing can get heavy payloads to space like a fully reusable multi-stage rocket. And the Starship is the model that is going to carry the most payload to space. Curious Borg says, if somebody gets on the space elevator and pushed all the buttons, would you be justified in pitching them out into freefall? Yeah, absolutely. Can you imagine someone pressing the 10,000 buttons? I'm trying to think how many floors, hundreds of thousands of buttons, and then the space elevator would stop at every floor. That would be like, you'd be off to The Hague for crimes against humanity. Ricky MCDD, why do they not use robots to fix the Hubble telescope, or is it just too old? Up until this point, they use human beings to fix the Hubble Space Telescope. And it's a lot of, like, some of the repairs were planned, but the original plan for the Hubble Space Telescope was they would take the telescope, put it into the shuttle's bay, bring it back down to Earth, fix it, repair it, upgrade it, and then launch it on another space shuttle. And it turned out that was just going to be too expensive and kind of dangerous. And so the astronauts went to space and they repaired it in space, which is amazing. And in fact, a lot of the instruments that they repaired were never planned, were never expected to be repaired. To get a robot to do that kind of tricky work today, I don't think we're there yet. So if Hubble needs another repair, I would not be surprised if something like, say, the Crew Dragon does it. It's not perfectly equipped for it today, but I'm sure someone at SpaceX, or maybe Blue Origin, is coming up with its version of it, where it can carry some astronauts to space, keep them alive for a couple of days while they make some repairs to the Hubble Space Telescope, give it another boost, swap out, fix some more gyros, and keep it going. When we near the end of the Hubble's life, which is coming up, say, in another 10 years from now, I think we'll have much better technology. You can literally just fly with a Starship and dock with Hubble, and the astronauts could get out and repair it and then keep going. So Hubble is still, and is going to be, until LUVOIR gets launched, is going to be the best space telescope humanity has ever launched. Across the wide range of wavelengths. I mean, James Webb will be out there, but crazy James Webb will probably die before Hubble does, because it's only got a 10-year lifespan, and while Hubble is going to keep going. So, Matthew Hansel, why are ion thrusters rarely used in space if they can produce tremendous speeds? It's interesting. The ion thrusters is a technology that's been developed for a long time. They've known about ion thrusters for decades. And it wasn't until, I think, Deep Space One mission, which was back maybe 15 years ago, that they had a bunch of these exotic technologies, and they gathered them all up together and put them into this one mission. They developed a star tracker, they developed an ion engine, and there was a couple of other interesting technologies. And that was a way to test, because up until this point, no one had been willing to put an ion engine into one of their mission critical spacecraft. But here we are now. The technology has been tested thanks to Deep Space One, and now it's been on Dawn, and it's been on a couple of other missions. So I think you're going to see them more and more and more. There was a moon mission, ESA's Smart 1 mission, and now, of course, the 60 Starlinks all have ion engines. So it's just how this works, right? The new technology is developed. It takes a while to trickle into various systems, gets proven that it works really well, and then they get developed. I mean, we're about to see the launch of the new solar sail that's coming from the Planetary Society. And the solar sail, right, is a technology that could theoretically provide thrust to any spacecraft for no propellant. So you could imagine putting on there's a lot of space missions that would have been saved if they had a solar sail on board. And when you think about Kepler actually sort of used solar sailing to stay oriented when it lost its gyros. So I think that that we're going to see this, now finally, right? The Planetary Society is testing out the solar sail technology. We're going to see that work, and then maybe one is going to be put onto the Deep Space Gateway, and then after a while, when a commodity version of this technology, you're going to see a solar sail module attached to almost any spacecraft that's going to be operating near the sun, because it's free propulsion. So it's just how this works. Things just take a long time. They unfold over long periods of time until they're sure they work. We're now looking at the potential of solar electric high power ion engines attached to the Deep Space Gateway, and potentially the one that's going to be traveling from Earth to Mars. So stay tuned. Dustin King, if Virgin Galactic gets on its suborbital flights down to $10,000 per flight, would you go on it? Maybe, after thousands of people have done it and it seems safe, which it's not. So that's it. Like, I would love to see the Earth from space. I would love to be at a high altitude. I just don't want to die doing it. And I know there's a lot of people that are totally worth who like Cody Don is ready to go to Mars and die there if he has to. He's brave, and not me. I like Earth. I'll stay here and cheer from afar. What was the question there? Okay, Checho, why don't NASA, SpaceX, ISRO, etc. come together and work for missions like Mars instead of spending money separately? They actually do come together. The International Space Station is the first obvious example of that. I mean, I forget the exact number of nations. 40 nations, as part of Europe as well. So you're going to see, in fact, NASA just announced all of the international partnerships that are going to be helping with the Deep Space Gateway and with their moon landing efforts. And I would not be surprised. And of course, SpaceX is going to be providing the Falcon Heavy to launch portions of the cargo ships that are going to be going. You've got all these private companies that are going to be sending science payloads to the moon. So international collaboration and private partnerships, that's the thing that's new. So we haven't really seen, like up until this point, you've had like NASA and other international partners, and they hire firms, aerospace firms, to do some of the design and development, like Northrop Grumman and Boeing and things like that. But I think this time around, you're seeing commercial partners that have already done the development all on their own, and they're providing a launch platform or a lunar lander platform, and NASA is just buying a ticket. And I think that this is what's new this time around, and that's what makes it pretty exciting. John Burr, what does that poster behind your head say? It says, "Gravity wells are for suckers." Josh M., will solar panels work well for Mars habitats, or would you need nuclear power as a backup? Solar power can work on Mars. Mars is still, the solar panels have to be a lot bigger, or the output from the solar panels is a lot lower. And that's why NASA has been developing a compact fission reactor called kilopower. And I think it'll just be a mix. You're going to see a mix of solar panels and fission reactors, depending on what they're able to take to Mars. But Mars is pretty much the farthest place that you can use solar panels. The Juno spacecraft is at Jupiter right now, and it has solar panels, and they're huge, and they deliver like 1/25th, I think, of the amount of power that we get here on Earth, and that's the end. If you want to go beyond that, you have to start building solar concentrators. So if you remember with the Expanse, they had these big parabolic mirrors that would concentrate the sunlight, and then you extract the solar power from the parabolic mirrors. And it really just comes down to, the farther out you go, it's more cost effective to build a big parabolic mirror, and then you concentrate that onto a smaller solar panel. And then closer in, it makes more sense to just build a solar panel directly and not use a parabolic mirror. So that's what you're going to see farther out into the solar system. And if we can crack fusion power, then it's a whole other world. But I think that we will see some fission reactors, especially for some of the, like when you need high power. So if you need like an ion engine that can produce a lot of thrust, you're going to need a compact energy source like a fission reactor that can put out thousands of kilowatts, tens of thousands of kilowatts. And so I think that's what you're going to see. Johnny Wednesday, would capturing dead satellites in orbit be a cost-effective way of obtaining raw materials for production? I don't think so. The problem with satellites and space junk and things is that each one is moving on its own special trajectory. And so for you to catch a booster, say a spent booster, an upper stage rocket, you've got to go you've got to match the velocity and trajectory of this booster. So you've got to essentially get your spacecraft into going 28,000 kilometers per hour in the exact same direction as the spent booster. And then you've got to do something with it, right? You're going to have to change its trajectory. So you're going to have to spend even more. And now you've got this heavy upper stage booster that you're trying to push into a new direction. It's going to be very expensive from a propellant basis to try and do this. Now, there's real value to clean up the space junk, especially the stuff that's in real high orbits. But I can't imagine there being a real economic model to go and then once you've got a complicated booster, you're going to have to dismantle it and turn it into raw materials. And that is going to be really expensive and really complicated and require very, very finicky work to tear it down when you could just have a factory sitting on an asteroid with little bots that are digging up ore and they're just dumping them into this factory, and the factory is spitting out I don't know, cell phones or whatever from the surface of the asteroid. So I think that is, you just got to imagine, right? Every single thing in the solar system is whizzing around on its own special trajectory, and if you want to do anything with it, you've got to put in all that energy to match its velocity, and that's expensive. Rami Imad, are there any more efficient and safer ways to land on Mars? Isn't this a limitation? I did a whole episode on how hard it is to land on Mars. So if you haven't checked that out, it's about maybe 5 or 6 episodes back on the Guide to Space. Highly recommend it. And I talk about all of the current methods, why they don't scale beyond about a ton, and what SpaceX is planning, and a crazy idea to essentially aim at the ground and then at the last minute pull up when you've still got the thickest amount of the atmosphere and use that to slow yourself down, which is scary. The Pewter Nerd. If SpaceX wanted to capture an asteroid, put it in orbit around the Earth, and then start mining it, who gives him permission? Does he have the right to call his asteroid his property? Good question. I know people bugs me when I say good question, but I think it's a good question. So, space law has not been fully defined. So the thing that has been defined so far is this thing called the Outerspace Treaty. And the Outerspace Treaty, and I've mentioned this several times, the gist of it is it's all about don't put nuclear weapons in space. So don't put nuclear weapons in orbit. Don't put them on the moon. Don't launch them from asteroids. No nuclear-powered super soldier training facility on the far side of the moon. No nukes in space. That is what the Outer Space Treaty is mostly focused on. And then it's like, oh, and also the solar system is a wilderness and treated with sort of the same rules as Antarctica. But there are no real provisions for living off the land when you're out in space. And so if you are setting up on an asteroid, there's no one to really stop you from dismantling the asteroid and turning it into Tesla cars. So have you ever heard this saying that possession is 9/10 of the law? If someone has a problem with what SpaceX is doing, then they have to stop SpaceX. And either they have to send the Space Force battlecruiser out to stop the SpaceX asteroid mining facility, or they have to put pressure onto Elon Musk here on Earth and seize his bank accounts and leverage him that way. So, but right now it has not been too fully thought of. Although there are some legislation that has been proposed by the U.S. over the last couple of years to start to define mining rights for companies. But that's a U.S. thing, but not an international agreement. So I think there is a gigantic update to the Outerspace Treaty that's going to happen, and I wouldn't be surprised if it gets that's when the Outerspace Treaty ends. That people are like, okay, no nukes in space, everything else is fair game, is where I think that will end up. Let's see. Brandon Warren, has any actual audio ever been recorded on any planet or moon other than Earth, not including InSight? Yeah. So InSight recently recorded audio, but it wasn't really a microphone. It was a seismometer that was designed to pick up wind. They were detecting the wind pushing it around, and they translated that into noise. So the only sound that I know of is that there was a microphone on the Huygens probe that landed on Titan, I think, and they wanted to listen to it. Now, there have been attempts to put a microphone onto like every single Mars spacecraft that's gone so far, all the rovers, all the landers, and it always gets removed. It always gets canceled because it's another piece of weight, and people are trying to shave down the weight on the lander and the rover, and so a microphone has never gotten a chance to go. And the Planetary Society is really trying to push for a microphone, but I don't think there is one. I don't even know if there's one going to be one on the Mars 2020 rover. So, but if anyone is watching and they work on any of these programs, I would love to hear what Mars sounds like. Like, it's one of the things I want to know the most. Is what does Mars sound like? Actually, what would Europa sound like with the creaking ice? Wouldn't that be cool? Or Enceladus? Or Pluto? Yes, please. Titan is all we've got. And I'm sure someone can dig up a link to the microphone, the recordings of Titan. Desway, doesn't it say weapons of mass destruction? Yeah, they you can't use telephone pole sized rods of titanium either. So no way of killing a lot of human beings from space. That's the rule. That's what the Outerspace Treaty is really focused on, is fine, go to space, just don't take your weapons up there, please. Which is going to make Space Force, if it actually has any kind of weaponry that's going to space, it will be a violation of the Outerspace Treaty. So, Dustin King, could somebody go out and capture the RTGs from spacecraft and use them to make nuclear weapons? Man, I can't think of a harder way to make a nuclear weapon. If you are capable of chasing down the Voyager spacecraft, you win. So, and you can do whatever you want to humanity because you are incredibly powerful. I, for one, bow down to you, Titan Chaser, the Voyager Chaser. Ben Kalo, is the number of stars in the Milky Way increasing or decreasing, and how do we know? So I believe there's 1 to 2 new stars forming in the Milky Way every year. And that's just off the top of my head. And now I need to look this up. Someone can double check me. And that number is decreasing. And we know because we know what stage the Milky Way is in, which is that it is already past the era of dramatic star formation, like most of the galaxies that are out there. The exciting time in the universe was about 2-3 billion years after the Big Bang. That was when the most star formation was happening. And now we are 10 billion years after that point, and the whole universe is winding down, and will do so for the next few trillion years until the last red dwarf stars die. So we've got about 10 trillion more years of slow winding down, and then that's it. So Now, you're going to have a period where we're going to have more star formation, like when Andromeda crashes into the Milky Way. That will give us a quick boost, but then it'll really settle down, because then a lot of that gas is going to all get used up, and then both the stars the two galaxies will mash together into Milkdromeda, and then it will just be this big giant elliptical galaxy. It'll turn red as all the stars die and just fade away. Let's see. 4 more minutes, and then I will wrap things up. There you go. So Desway is saying, according to NASA, in 2006, it's 7 per year. So I apologize. Ricky MCDD, do you think that we will ever have superluminal communication? So will we have a way to communicate faster than the speed of light? I don't know, right? We never know what the future holds. As we understand it today, there is no way to communicate faster than the speed of light. It would violate the laws of physics as we understand them, but many of our discoveries have come from us realizing that we didn't understand the laws of physics correctly. And so we will have to figure that out. But for now, we have no way of knowing that it will be possible, which is sad. But I can be patient. Wait 4 years for play a game of Fortnite with someone in Alpha Centauri, and you have to wait 4 years for that ping time. That would suck. Neil Yu, what is the punishment for violating the Outerspace Treaty? Good question. I said it again. I don't know. I mean, how do you punish a country that has decided that it's not going to listen to an international agreement and put a bunch of weapons of mass destruction into orbit, where they can begin annihilation, Armageddon, with 5 minutes of notice? I don't know, sanctions, you trade agreements. As long as any civilization has things here on Earth that they care about, that's how you stop them and you leverage them. And you say, well, because you launch those please, don't launch nuclear weapons into space, or you will not be able to trade with us anymore. I don't know. It's tough. All right, we're about 2 minutes left. So before I go, I want to remind you again, this whole chat will be available as a podcast, as will all future chats. All of the audio, all of the stuff I do for the Guide to Space, all of the question shows, all the live stuff, as well as all the interviews, as well as random stuff that I do from time to time, that all goes into my podcast. So go to universetoday.com/audio. And also just working on the new newsletter that's going to be coming out on Friday. And I think that is like the favorite thing that I do now. So if you are interested in like a weekly breakdown of all the things that's happened in space and astronomy for the week, I write each one by hand. Go to universetoday.com/newsletter and you can sign up. Ad-free, totally free. I think you'll really enjoy it. All right, well, that was awesome. Thanks, everyone. Just a reminder, I've got 2 more episodes. So next week will be the penultimate episode, and then the one after that on the 24th will be the ultimate episode before we go on to the summer hiatus, which starts at the beginning of July, ends at the end of August. So 2 more live open spaces before we go through summer. But again, thanks everyone for watching. Thanks for all the questions. That was awesome. I really appreciate it. Always fun. And I will see all of you next week. This week, the next episode, probably coming out tomorrow, might be Wednesday, is all about the continuation of extreme life forms, essentially planetary protection. How do we stop life from getting to Earth? How do we stop Earth life from getting to Mars? How is SpaceX going to set up habitation on a world and not contaminate it? So that's what it's all about. And then I think I'm working on nuclear rockets the week after that. So, all right. Thanks, everyone. We'll see you all next week.